As an exercise for converting descriptions to formulas, I'd like you to have a go at this problem, building a multiplexer, or a mux, and a demultiplexer, or a demux, using the common logic gates that we've already got. So first off, what does a multiplexer do? So a multiplexer takes two inputs A and B, and a third input S. S is called the selector input. And what the multiplexer does is that if S is equal to 0, then the output Q is equal to whatever the input A was. Otherwise, Q is equal to B. So you can imagine this thing as like a switch almost. And what it does is if S is 0, it just copies the input A to the output Q. And if S is 1, the switch flicks over and it copies the input B to the output Q. So based on that description, draw a truth table and then convert it to a formula. And then a demuxer sort of does the opposite. So it takes one input and chooses between two outputs. So if the selector is equal to 0, then the output Q1 is equal to A, and Q2 is just set to 0. Otherwise, the output Q2 is equal to A, and the output Q1 is just set to 0. Because we have two outputs, we always have to be returning something. I can't leave an output like undefined. So wherever the input isn't going, we just set it to 0. So from these descriptions, work out the truth table, and then work out the formula for these, and then work out how you can build this thing out of the common logic gates we've already got, just like we did for the majority circuit example.